So ratios are a way of expressing one thing compared to another. So for example, we write it in the form x to y. We can also add more x to y to z, but we'll talk about that later. So if x is 1, for example, and y is 2, then this ratio here, 1 to 2, tells us that y is 2 times bigger than x, and x is half as big as y. Now, what we can do, we can do a lot of things with ratios. To begin with, we can convert them into other values. So, for example, here we have red to blue counters in a bag are in the ratio 3 to 2. When you get an example or question like this, you need to realize that it says 3 to 2, so the first thing mentioned will be the first in the ratio, and the second thing mentioned will be the second thing in the ratio, unless stated otherwise. So we can convert these into fractions, for example. So we can say there are 3/2 as many red counters as blue, because if you multiply the 2 by 3/2, you get 3. And conversely, you could say there are 2/3 as many blue counters as red. Or we can do other things. For example, when we think of a ratio, we think of it as in parts. So this is 3 parts here, and this is 2 parts. And later we'll learn about how we can convert parts into real values. But for now, just understand that we relate to these, the term we use for these is parts. So the total number of parts, is 2 plus 3, which is 5. So we can also say, for example, 2 out of 5 of the counters in the bag are blue. So instead of comparing it to something else in the ratio, we've gotten the total amount of parts, which is everything in the bag, and we've said that 2 out of 5 of the counters are blue, and clearly 3 out of 5 will be red. And because we can convert it to a fraction, we can use our FDP rules, so 2 out of 5, to say that that's also equal to 0.4, or we can say it's equal to 40%. So really, we can convert ratios into fractions, decimals, or percentages. Okay, we can also scale and simplify ratios. So, for example, if we have the ratio 3 to 7, let's say, we can multiply that by any constant here. So we can multiply it by 4, for example. We'll get 12 to 28, because we multiply the 3 by 4, we multiply the 7 by 4. So it kind of works in an equation in the sense that if you multiply one side by 4, you have to multiply the other side, or all of the parts of the ratio. So this is the same ratio as this. It's the same thing. It's just this has been scaled by what we call a scale factor of 4. So that's what we can do. We can also divide. So we could divide this by 4 again, if we wanted to go back to the original. And these don't even have to be whole numbers. We could divide by 3, and we'd get 1, 2, 7/3. And this is called the ratio in 1 to n form. It's something you need to be able to do. So whenever asked for it to be in 1 to n form, you just need to divide one side, this side, by 1, and then the other side will not be equal to 1 usually, and that's 1 to n form. So for example, let's try right, let's do 9 to 5 in 1 to n form. Okay, so we want 9 to get to 1, so what we need to say is, what do we need to divide 9 by to get to 1? Well, we divide by 9 because anything divided by itself is 1. So we've got into 1. Now we just need to also divide this side by 9, because we do it to both sides, to get 5 over 9. And that is in 1 to n form. Now, for example, what we can do also is simplify ratios. And like in a fraction, like when you're dealing with a fraction, the simplest form is when it doesn't have any more common factors. For example, we can say simplify 15 to 30 to 24. Now, what we can say is this isn't in its simplest form because each of these are divisible by 3. So what we can do is we can divide this ratio by 3 to get it into its simplest form. So divide by 3, divide by 3, divide by 3. And then, or you can write that, or you can just write a simple divide by 3. As long as if you realize you're dividing everything by 3. So we'll get 5 to 10 to 8. And this is our in the simplest form, because you can't take any more common factors out without it becoming a decimal. So that's what it means when it says simplify or write it in the simplest form. Okay, so now that we know that we can scale them, we can start tackling more difficult things. And these last 3 examples really show the difficulty in ratios, the most difficult bits. So we can write ratios as part to whole ratios. So the example says that Adam has some apples and oranges in his bag. The ratio of oranges to fruit in his bag is 2 to 7. So you've got to realize that the 2 is the oranges. So the 2 is the oranges. In fact, let me do it in a different color. Well, orange seems the most fitting, so we'll do that. And then we'll say that the fruit is the 7. That's what we need to realize, because the oranges are 2 parts, so this is 2 parts, and the fruit is the 7 parts. And now we want the ratio of apples to fruit. So what we can say is, well, the fruit is the total amount of parts, isn't it? So what we can say is that, well, that if 7 is the total amount of parts, because that's the apples plus the oranges, so we can say apples plus oranges equals fruit, right? The total fruit in the bag. So we can get the parts of the apples and the parts of the oranges and add them together to get the fruit. So the parts of apples plus the parts of the oranges, which we know is 2, equals the total amount of parts, which is 7. So if we subtract 2 from both sides, we get the parts of apples to be equal to 5. So if we wanted to write it in the ratios of apples to fruit, we get the parts of the apples, so that would be 5, to the parts of the fruit, which we know is 7. 5 to 7. And then for B, we want the ratio of apples to oranges. So we know the parts of the apple is 5. And then we want the parts of the oranges. So that's 2. So we have 5 to 2. Like that. Now this last part, it says that Adam has 4 oranges. How many apples does he have? Right. So this is where scaling really comes into effect, because now what we can do is we've got this. So this is the apples to oranges. But this is in ratio part. So this is just a proportion here. But we want it to convert these parts into the real values. So 4 oranges. So we need to say, if this here is the orange, denotes the oranges, or the proportion of oranges, we need to multiply this by something to get to 4. So what we can say is we can multiply this by 2. And now we'll have 10 on this side and 4 on this side. So we know if Adam had 4 oranges, he would have 10 apples, because we've scaled it in such a way that now we know how many apples he'll have. So that means Adam has 10 apples. Okay. So now we can divide amounts into ratio as well. So here we have Aaron, Kim and Paul splitting £6,000 in the ratio of 3 to 4 to 5. And we want to know how much money Aaron receives. So again, we can underline the ratio of each person, like so. So we know which ratio is whose. So what we want to do is we want to find the red ratio, because we want the money that Aaron receives. So how do we convert this into the real value? Well, the thing is, we don't actually know how much each receives, but we do know the total amount that they split. So if we find the total number of parts and scale that, we'll be able to find out how much each receive. So let's find out the total amount of parts. So we get 3 plus 4 plus 5, because that's total, and then we get 12, like that. Okay, so that's 12 parts in total. So what we can say is we can find, and that equals £6,000, 12 parts. So what we can do is we can divide both by 12 to get one part of the ratio. So if we divide 6,000, let's get rid of the units for now, and if we divide that by 12, we get 500 pounds. So that's one part. You can see that we've connected the amount of parts in a ratio to that real value, so the thing we actually want to deal with. So now, and then we've divided by 12 to see how much that is in one part. Now, what we can do, but we don't want one part, do we? We want 3 parts, because that's how much Aaron receives. So what we can do is we can multiply this by 3 to get 3 parts. So that equals 500 times 3, which is £1,500. And that is the amount of money Aaron gets, or Aaron receives. Okay. So what you can think about is that step 1 is to add the ratios together, or add the parts together, and then step 2 is to find one part. So find total parts. Step 2 is find one part. Step 3 is find desired parts. But I wouldn't think of it in these steps, because if you can understand the theory behind it, that's much more beneficial, because you're not always going to get it like this. Sometimes, for example, they won't give you the total, but they might give you some other information. But in this specific kind of question, that's the steps we took. Now this final example is by far the hardest, and it's when ratios change. So you have ratios beforehand and then ratios afterwards. So, for example, here it says that Billy and Claire share marbles in the ratio 5:3. Billy gives 4 marbles to Claire, and the ratio is now 1:1, 1:1. So, how many marbles did each have initially? So, what we can say is that when you're tackling this, it's always nice to use algebra. So we say, first, Billy, so initially, or before, we could write, before would be a bit nicer. So before, Billy had 5x, has 5x marbles. And Claire has 3x marbles. The reason we can write it in this form is because it doesn't matter what x is, Billy's always going to have 5/3 times more marbles than Claire. So this ratio here will still hold no matter what x is. So now we say that after Billy gives 4 marbles to Claire, we know that now Billy has the marbles he had before minus 4, because he's lost 4 marbles to Claire. So now he has that many, and Claire has gained 4 marbles. 3x plus 4. So her old amount increases by 4. And now what we can do is, we know the ratio is now 1:1. So we know that 5x minus 4 is equal to 3x plus 4. Because that a 1:1 ratio just means they're equal to one another. Or what we could say is, we could write it like this. So this is the same as 1:1. So what we could do is we can write that in the fractional form, which gives us 5x minus 4 over 3x plus 1 equals 1. Because obviously they're the same, so if you divided one by the other, you would get 1. And then you can multiply through by 3x plus 4 to get 5x minus 4 equals 3x plus 4. And now let me bring this up here. So we have 5x minus 4 equals 3x plus 4. Now what we can do is we can add 4 to this side, add it to this side to get rid of the 4. We can also minus 3x from this side and this side to get rid of the minus x. So now we have the x's on one side and the constants on the other. And now all we need to do is divide by 2 to get x equals 4. So that is what x is. But remember, it's asking for the amount of marbles they had initially, so before. So all we really need to do is substitute x back into these initial values. So Billy has 5 times 4 are 20 marbles, whereas Claire has 3 times 4 are 12 marbles. Those are your answers. Now that's probably one of the hardest ratio questions you're going to get. So if you can do that, you can do it all, really. So yeah, right. So here's some exercises for you to try, with exercise 3 having 2 parts.